This is the CNC Router Tips Podcast, episode 38.
To me, it's not so much the fact like it's entrepreneurial, like I enjoy it, but it's the fact that by being entrepreneurial, you have the chance to change the world and affect it like by creating something new. If I worked at some company, I would just be creating what they wanted to create. I couldn't make my own decision and say, hey, people out here need the ability to make stuff on their own. I wouldn't be able to make that decision.
This is the CNC Router Tips Podcast, a show which answers one question from you, the listener, about CNC router tables, CNC software, hardware, web hosting, and business. I'll help you get started in your CNC hobby or business and help you cut through the confusion.
Today's episode is sponsored by themakersguide.com. The Maker's Guide. Useful tools for makers.
Hello, everyone, and welcome to another episode of the CNC Router Tips Podcast, a show which talks to you about using your CNC router table to create a business or to use for hobby or just plain enjoyment. Today, I'm honored to have two young guests with me today who are doing something rather unique. They have launched a project in Kickstarter to bring a CNC mill to market. And what's really impressive about these two guys is they're students at the University of Waterloo in Canada. So I'd like you to please welcome Andy Lee and Chris Thorogood. Hi, guys.
Hello. Hey. How's it going?
Oh, it's going excellent. So just so our listeners know the voice, say hello, Andy.
This is Andy here.
And Chris?
Hi, I'm Chris.
Okay. So you guys are students at the University of Waterloo. What program are you studying? So
Chris and I are both in mechanical engineering. So we're just about finished the second year of our we're in the middle of the second year of our undergrad right now. Mm-hmm.
Is it a 2-year or 4-year program?
It's a 4-year program.
Okay.
It's a 5-year program because in between study terms we have co-op terms.
Mm-hmm. Okay. So you guys, with really very little school time, have decided to go in and tackle a project of bringing a CNC mill to market. What is your project called?
The name of our machine or the name of our company or what's okay. So CNC Labs is the name of our venture. It's the story behind it is I used to work as a CNC programmer for these really big steel cutting machines. Mm-hmm. And then I took another job working at a startup, and I was designing these robots that hand wrote. So the idea behind it is basically, sometimes you get a piece of mail, like junk mail, in your mailbox, but you're not likely to open it, so you throw it out. But this company basically wanted to use CNC machines to handwrite the letters so people would open them. So I was designing the machines for that application, and using that two pieces of background knowledge, I decided to start working on linear motion systems that were really low cost for rapid prototyping. So Chris and I have been working on doing some prototypes in the very beginning, starting in January, and then later on, we decided we need to take the stuff that we learned from doing all our research and then see if we can put it into an actual machine. So maybe you can talk about the 3D printing market and why we chose CNCing.
Yeah. So where I was able to contribute what I know is I have a large background in 3D printing technology. I've had my own RepRap printer for a while. I built it about 3 years ago. And so Andy and I have both dove into the 3D printing world and kind of have a great understanding of where the market currently sits. And so that was able to give us a good gauge as to kind of the density of the market and where it's at right now. And we realized that with this linear motion system that we'd come up with, we could take it and incorporate it into a machine. So we were considering maybe 3D printer, maybe a CNC machine, but we decided that there was kind of a lack in cheap CNC machines available on the market. And so that's kind of what we ended up aiming for.
Yeah, we found that the 3D printing industry was really saturated. And to really make an impact, you can't just build another 3D printer because there's so many 3D printers out there. But seeing we had a chance of creating something new, so that's why we chose that.
Okay, now it may amaze some people that you can become an expert in 3D printing in 3 years, but realistically, the home-built 3D printer market is only about 4 or 5 years old. No, I got to take that back. 2010, I think it was 2011. I went to the Consumer Electronics Show in Las Vegas and met with the folks at MakerBot there. So that was the first year they were there en masse. So it's about a 6-year-old industry, really. Yeah. So that's very cool. Now, how old are you, Chris?
I'm 19. So is Andy.
Yeah. So you're two sophomores, basically. 19 years old.
I have 3 years of experience through FIRST Robotics. So that's what I was able to offer. Andy actually doesn't have any robotics experience. He just has a lot of tinkering experience.
Yeah, I used to live on the West Coast and kind of in the country. So like all that people on that side like talk about is like smoking weed and drinking. How much they drank over the weekend. So like what I taught myself how to like solder and weld and do chemistry and like stuff like that. But yeah, I never got the chance to do any of that sort of thing in high school. But I got the chance to start my own radio show with a friend. That was fun. Yeah, and did a lot of musical theater. So I got kind of cool. different skill set in the past.
Yeah, it's nice. While your friends are out, partying all weekend, you're making cool stuff. I like that work ethic.
I mean, yeah, and my experience is like much different than Andy's. Like I also did a lot of stuff in my own time, but my high school had a few more opportunities for learning, so I was able to take programming courses and electronics courses, and I took the same woodshop course at higher and higher levels throughout the 4 years I had in high school, and I got a 99% in the class every year because I just really like building, and so it was through FIRST that I was able to learn more about robotics, and I actually, because of FIRST, I started a robotics club at my school, and like now I've had the experience of like being an actual robotics teacher for one of the co-ops that I was part of. And so, yeah, between Andy and I, like, we have a lot of formal and informal training in a lot of different areas of expertise. So
yeah,
that's kind of like what we're able to bring to the table, so we can use whatever hat suits the task at hand to kind of evaluate, like, is this going to work and how's it going to work, whether it's building something or marketing something or trying to get into the head of the consumer.
We got a pretty eclectic skill set.
You bring the knowledge that you developed from experimenting with 3D printers and robotics into this, and you decide to make a CNC router or mill, as you refer to it in yours. Why did you decide to focus on the lower cost solution rather than going whole hog and building a bigger, more expensive machine?
The vision for our company is to be able to make it possible for people to create really cool things and make those really cool things really easily. And the biggest two factors that prevent that from happening is the cost and ease of use. So in terms of cost, you can buy CNC machines for $1,000, $2,000 or more. But for a beginner, it doesn't really make sense to put that sort of investment in for a machine that is going to take a long time for them to learn and get use out of.
Why do you think that it takes them so long to learn how to use them? What's the holdup in your opinion? I have mine.
Well, obviously, like with people with a technical background, it's easy for them to understand how it works. But I've personally had the experience of teaching like business people how to use CNC. Like even engineers that have never done CNC programming, and it's a learning. There's like a pretty big learning curve, and it's a little bit daunting because you're working with a pretty heavy tool. So I personally think that learning how to use the CNC machine isn't hard, but it is to a lot of other people.
Mm-hmm. And it's actually interesting you bring up MakerBot and seeing them at CES, because that's kind of the approach that we're trying to take with our machine. We've noticed there's like CNC machines have been known to be more expensive, but they're also much older technology. And so the way we like to think about it is the way that MakerBot kind of allowed, and some of the technology advancements around that time allowed for 3D printing to come to a desktop version. And over the years, the prices have slowly dropped off. It's nice to also make the other side available, which is the subtractive technology of CNC machining, because 3D printers are great, but they can only do stuff in plastic. And CNC machines pick up where 3D printers kind of leave off.
One of the main hurdles that everyone... Now, I have a Facebook group that is all about CNC router tables, and we have a lot of beginners on that group. And one of the things that always pops up as a stumbling point is the software, getting to know the software, the processes behind how you're going to machine something. What is it that you guys will be bringing to the table that will make it easier for a beginner?
So in the terms of the software side, there's been a lot of advancement in the back end, like with Gerbil and stuff. Since there's a lot of open source and really powerful processing done on microcontrollers and things like that, that's become a lot more simpler. And in terms of the front end, for us, since we aren't really experienced in developing software, we've partnered with other companies that develop software. And what they offer are like browser-based software for designing objects, and then you can go right away and do the CAM for it, so computer-aided manufacturing. So if you've ever used a 3D printing slicer, it's really similar. Like the one that we like using is called Kirimoto, and it's developed by a fellow named Stuart Allen. Mm-hmm. And the story behind Kirimoto is that he wanted to develop a 3D printer slicing software, and when he developed it, he found that it was applicable for using for a CNC machine. So he developed the side where you can generate the G code or the commands to go to the CNC machine using the core base of that slicing software.
Mm-hmm. How is that spelled, by the way?
Kirimoto spelled KIRI:MOTO. And if you want to check it out, you can go to grid.space, which is grid.space.
All right. So this is the software that you're using for the actual operation of the motors and the stepper drivers, replacing something like Mach 3 or UCCNC, which are programs that we would be familiar with, or is this the design software?
This is the CAM software that we're using. For any interaction directly with the machine, we've been using Universal G-Code Sender or any other Repetier hosting software.
Okay, so you're sticking with the 3D printer way of thinking to use the smaller post-processor. So from the design side, what are you guys doing?
So for the design side, like I was saying, we wanted to make it inexpensive. So when we started designing our linear motion systems, the goal was to create something really versatile and really simple. So the core aspect is using V wheels and using a 90-degree angles. So in the beginning, we used steel, hot rolled or cold rolled steel plate, and then milled edges on them so that V wheels could travel across them. And that was really good for high speed applications for like 3D printing and such. And one day I had a piece of angle aluminum, and I thought, hey, if I turn it 90 degrees then or 45 degrees, you have like the two edges that you can use V wheels on. So as you can see in our design for our CNC machine, that's what we use, and inside the channels we have lead screws. So that was really an inexpensive way of going about things.
Okay, and for those who would like to see what the design looks like, they can go to CNC Mill One in Kickstarter. So that's on Kickstarter.com. And if you just type in SIENCI Mill One into the search, it will bring you to their campaign.
Yeah.
So now, you mentioned a little bit about the design of the machine, but how are people going to design their projects in 2D or 3D? What software will your machine support?
Yeah, so we've been talking back and forth a lot with Onshape. The guys over at Onshape are really cool because they've been able to offer basically a free version of SolidWorks online. And so if you're trying to get an introductory into that sort of 3D modeling, or if you're used to SolidWorks and you don't happen to have a license currently, the guys over at Onshape are nice. And the website's good because it's very intuitive and it's all cloud-based. So your computer doesn't have to possess all the processing power that you'd normally need for a 3D modeler. Instead, all the processing happens online.
Now, just to be clear, this is a program that's similar to SolidWorks, or it's a version of SolidWorks?
It's similar to SolidWorks.
Okay, yeah. So anyone who's familiar with 3D modeling in a package like that, where it's parametrically based, should be able to learn Onshape.
Yeah, it's very, very easy to pick up. I mean, even Andy and I, we've been in situations where someone's like, so can you give me a quick rundown on how to use this? And we hadn't even used it at that point. And in the time that we were using it, we had taught ourselves how to use it to teach someone else how to use it. So it's very, very intuitive.
Excellent.
Yeah. But if you're more familiar with like Blender or like other modeling software, it's still okay, because as long as you can export 3D files, like for example an STL or an IGES, you can still import it into the CAM software that we use. So, yeah.
Okay. So now I know I've got you bouncing back and forth around on topics, but let's talk a little bit more about your machine. Now, this is in the desktop class of machine, so how big a cutting area are you offering, and are you planning to offer more than one size?
So the cutting area on the CNC Mill One is 250 millimeters by 200 millimeters, and then the Z-axis travel is 100 millimeters. So for people who don't know a lot about CNC milling, the thickness of the material that you can cut for a 3-axis machine. So basically all of the CNC machines that you can afford basically are 3-axis machines. They're limited by the length of the cutting bit that you're using. So we have 100 millimeters of Z-axis travel, so you can fit fairly thick materials in, but it depends on what sort of bit you're using to get that full advantage of that travel.
Okay, so for those of our listeners who don't do the metric system, so 250 millimeters is 9.8 inches.
Oh, okay.
Wow.
9.8.
And,
So just under 10 inches, I guess.
and the other is 7.8. So you're figuring 7 3/4, 9 3/4, around in there. So you're good size wise, it's nice for some of the smaller projects that you could do, and you can do a lot with that. Yeah. So okay, cool. So what type of processing power are you using for this? Is this Arduino based, Raspberry Pi, TinyG? What is it?
So in the back, there's an Arduino, and we have a shield on top of it. So there's the Arduino circuit board, and then on top there's like another circuit board that kind of sandwiches on top. And then sandwiched on top of that, there's like little chips that have drivers that power the motors. So
the shield that we're using is a CNC shield for the Arduino.
Okay. And how many amps will that support? Do you know?
So each driver has a maximum current about 2 amps or about 2.5 amps.
Okay.
Yeah.
And you're using what size frame motors? NEMA 17, NEMA 23s? What size?
Yeah, so we use NEMA 17 motors. The ones that we have right now are 1.5 amp, but we're looking into sourcing some maybe 2 amp motors or seeing what else there is. But we have a reason behind why we decided to use NEMA 17s, which is basically they're easy to find and they're not so powerful that it'll break your machine. So yeah, NEMA 17s.
Yeah, if you have a crash with a machine powered by a NEMA 17 motor, chances are that the motor will stall rather than crash and break something.
Yeah.
So
we also do get a lot of questions by some people who are interested. They're like, wouldn't the motors not be powerful enough to cut through the materials you guys are cutting through? But we've run our machine for hours and hours and hours on many different materials, and we can assure they never overheat. They can handle anything that you throw at it.
For those of our listeners who are still new to CNC and don't really know what we're talking about when we talk about NEMA 17, NEMA 23, NEMA 34, it's just basically a different standardized measure of the mounting brackets for these different motors. So physically, a NEMA 17 is smaller than a NEMA 23 motor. So that's all there is to it. All those motors will move something. But,
I believe a NEMA 17 is 1.7 inches or 42 millimeters.
Mm-hmm.
Yeah, and then they increase in size from there.
Yeah.
Well, you can get NEMA 14s and NEMA 7s, I think. Yeah, but we're off topic.
So now, what do you envision this? What's your dream when you're thinking about this? Getting the Mill One out there. Where do you see it going? Who's going to be the user?
Well, obviously, for what we're offering for the machine, we think we probably could have increased the price, but I think what our main goal is to add the accessibility factor of CNC machining for anyone who may be looking to get started in this area, or even people that are more experienced with CNCs. Maybe they just haven't gotten around to buying one because they don't want to buy an expensive machine, or maybe they're looking into making a multiple machine purchase but don't need anything that big. Then this would be great to apply to whatever at-home project they may have.
Mm-hmm. Yeah, I could see this going into a lot of maker spaces and schools area, because it's not an expensive item on the budget. What is the cost of your machine right now in this Kickstarter project?
Our basic kit goes for $400 USD.
Okay. And how about all tricked out? And what does that include?
So if the all tricked out machine would be, it's fully assembled. You get a spindle. It has a black finish, and you get those three things, and it's about $830, which is Canadian, which is
about 644 US dollars. It says here. Yeah.
So, okay. Let's say about $700 probably.
Sure. Now, just one thing that we didn't go over. This you're showing in your video. This is in a little enclosure with a plexiglass window and everything. Is that the way that you plan to have them out there?
Yeah. So the reason why our design is kind of like in a big box is because previously in our previous iterations we had an open style machine, close to like a classic gantry style CNC machine. But if you're putting it in your room or if you're putting it in a dust sensitive area, it sucks if you want to clean it up. And when I first started designing this machine, I only had access to basically my bedroom. So I did one test and I decided, okay, like this doesn't work for me. So after that, I decided we're gonna build a box structure, and it made sense because it was much stronger. It looked a lot nicer, and especially with that dust not being able to get out, that was really good.
Yeah,
and I think
was it MDF that you were cutting?
Sorry,
were you cutting MDF on your first project?
We are cutting like particle board and like pine as our first couple of tests.
Yeah, very dusty. Okay.
Yeah. But it's been good because having a a semi-closed enclosure means it's a little bit safer as well. If you have children or something that want to put their hands in a spinning tool, it helps prevent that as well. So.
Mm-hmm.
Okay.
But the removable shield at the front allows you to quickly switch in and out router bits and remove your piece.
Yeah.
So that's why it was included.
Yeah.
Okay. Now, there are 3 members in your team. Who is the third member?
So Tim right now is working on Excel. His background is in materials research. So right now he's working on developing these crash structures for cars that are supposed to make it a lot lighter and a lot safer. So, yeah.
So very cool. So tell me the backstory. How did this all come about? I mean, you guys are sitting around one day. What was that like when you said, "Hey, let's build a CNC router"?
So, like I was saying in the past, I worked at this startup building these robots, and during that time, I was the only engineering student or like engineer in general in the company. There's 4 people, and all the 3 were in business or accounting. And the CTO had left, and so I was working with the Shapeokos that basically had pens and they would write letters and stuff. But the success rate on those was really low, like 80%. So if you're writing 1,000 letters, like 200 of them would be garbage. So I said, okay, we need to make it automated and we need to make a better machine. So I designed a better machine, and during that time, I told the CEO, like, hey, I think I can probably build a CNC machine kind of like the Shapeokos now, but a lot cheaper and a lot stronger. So he was like, yeah, you should like try it out. And we had like a lot of discussions about what it's supposed to be like, what people really need, and a lot of other things that I learned a lot of stuff. So after taking all the things that I learned from that job, I decided to go into a business course that taught me about how to start a venture and the thinking process of it.
Was this a course at the college?
Yeah, it was at the university.
Mm-hmm. Okay. So you decided to double down and gain another skill, because most engineers are not entrepreneurial. That's really a unique mix. That's why you have standouts like a Brie Pettis or a Lady Ada from Adafruit, or because they combine multiple skills.
Mm-hmm.
It's funny. I look at you guys, and and I look at some of the students that I've had, and you two are actually going for it. And a lot of them, their thoughts are, well, I will go and work for someone. And yours is, no, I'm going to go work on something. Versus, it's a slightly different mindset because many of the MET people are not entrepreneurial. They like to make things, but they don't necessarily see the business side of things. So that's kind of cool that you guys do.
To me, it's not so much the fact it's entrepreneurial, I enjoy it, but it's the fact that by being entrepreneurial, you have the chance to change the world and affect it by creating something new. If I worked at some company, I would just be creating what they wanted to create. I couldn't make my own decision and say, hey, people out here need the ability to make stuff on their own. I wouldn't be able to make that decision. So I love being able to make a change in the community just by being a business person myself.
Yeah, the nice thing about being a startup or being a small company is the agility that you have available to you, so that we don't have to be going to people above us and making sure hey, is this okay before we start doing it, or putting all of our decision-making progress through it, or trying to get funding for our branch of the company or anything like that. We started the company, so we get to decide where we put our progress into and what we put our efforts towards.
Mm-hmm.
That's awesome. That's lifestyle independence as well. So that's awesome. So how did you choose your team?
Well, Chris and I have lived together for 8 months, and we're really good friends. And since he has a lot of tools and a 3D printer, and I had nothing, it kind of worked out. And plus, Chris is pretty experienced in design because he worked at NCR, which is a really big ATM company, and then also a really
National
big
Cash Register
company. So
yeah. Andy and I were able to work really well together because I was able to supply the tooling and the machinery we needed to initially get started up, as well as both of us have a lot of experience in mechanical design.
Yeah, and I'm also really good at cooking. And Chris cleans the kitchen up after me, so as roommates, it works really well.
So now, do you have through the school you took this course on business, bootstrapping a business? Are you using advisors at the college to help you, or are you guys just out there on your own giving it a shot with Kickstarter?
So we kind of have mentorship with our professor, but most of our mentorship comes from the Small Business Center in Kitchener. They have a program called the Summer Company where you have access to money and also mentorship. So that's been really, really helpful. And it's the part of the program is also training as well. So learning how to do accounting, learning how to do bookkeeping, sales, marketing, and a lot of other stuff. That was really, really helpful. So, yeah.
From concept to launching your Kickstarter campaign, how long did it take you guys?
8 months. It's kind of fuzzy because in May I decided to work on this full time during the summer. So before that, that would be about 3 or 4 months, and then before that, I was kind of working on it on the side. So I would say the whole process probably took almost 8 months.
Okay, so now Kickstarter, for those in our audience who aren't familiar with it, is a time-sensitive thing. It is a website which allows you to order a product from a company before it's made. In fact, you're backing their manufacturer of this product. So the risk is, can they make it? the upside is you get it before everyone else. So the other thing about Kickstarter is it's an all or nothing proposition. If you don't meet the goal that you've set, in your case, 60,000 Canadian dollars, then you get nothing, and you don't have to produce the product, so you're not out all that money.
Well, we want to.
Oh yeah, I want you to. I think it's a pretty cool project. So you guys weren't intimidated at all by the thought process. What were you thinking, Chris?
Well, basically, when it came down to our machine, our price point is about 500 Canadian or 520 Canadian for your most basic setup. And we had already gone out to Hamilton Maker Faire, Toronto Maker Faire, and a lot of other events where we were able to talk to the people that we knew would be interested in our machine, people that had experience with 3D printing, CNC machining, or other tech startups. And we were basically, based on that, able to gauge kind of what's the interest in our product. And so the number that we came down to was, obviously we need to launch a Kickstarter because it'll allow us to order the materials that we need to build these machines in bulk, which will enable everyone who's interested in the machine to get it for the cheap price that we're able to offer. And the number we arrived at was 100. We knew that we could probably sell 100 machines based on this interest that we had gained from having the idea to showing it to people and seeing what they thought. And so at about $500 for the basic kit and about $820, and this is all Canadian, by the way, for the most advanced kit, we thought that that times 100 machines was about 60,000. So we thought, why not go for it? 100 machines is probably the minimum we'd want to make. And so far it's paid off. We're only a week into our 4-week campaign, and we're already halfway there.
Mm-hmm. How much have you raised so far?
We've raised 30,000 Canadian.
Okay. Out of a 60,000 goal. So you're halfway there. Okay.
Yeah. And the important thing is that Kickstarter is full of projects, but they're often late or disappear. The way that we kind of confirmed that people wanted our machine and it was something viable, like it was useful to them, was by actually building kits and selling them. So we've actually sold 4 of them, and we've gotten pretty good feedback from that as well. So we have an idea of what it takes to build it, how much it will cost, and a couple of other really important information that we need to make sure everything runs smoothly.
Yeah, I about 2 or 3 years ago when I was considering doing a Kickstarter project, I read this really good book called The Kickstarter Handbook, and it's by Don Steinberg, Steinberg. One of the facts that he quoted from interviewing folks who had done Kickstarter projects was that you are 95% likely to succeed if you achieve 50% in the beginning of your campaign, 50% funding. So you guys have already hit that in how many days was it? 6 days?
In 7 days we've reached halfway.
Yeah. So, that's a really good sign that you're very, very likely to have this be a successful campaign completed, and then you'll have just to worry about producing all of those machines.
Yeah.
So that's very cool. Congratulations, guys.
Thank you.
So the next question I have for you is, how do you intend to fulfill all of these orders from a manufacturing standpoint? Neither of you have ever been directly involved in manufacturing the parts that you need. Are you going to outsource them? Are you going to do them in-house? How are you going to handle that?
Well, actually, what's nice is when it comes down to other Kickstarters and they talk about, we need your backing in order to mass produce these machines, usually they have not, up until that point, even spoken to a manufacturer outside. We've actually already done all that work. We've spoken with manufacturers that are both local and distributors offshore, and we already know what price we'll be paying for components that we need for our machines, and at what quantity would make the most sense for us to order it. And so the nice thing is that we've already got these all in place. So it's just once we have the number of machines that people are going to be buying, we can basically just go back to our manufacturers, tell them, all right, this is the number, and then they can already start producing the parts that we need.
Yeah. So if we meet our goal within,
when?
like when we meet our goal, even before September 17th, which is the last day, like we'll probably already have ordered the parts because we're in the talks with a really good friend company of ours that have 3D printing services, and they offered so they told us, I told them this is the cost of what these parts are going to be in metal or a different material, and they said, okay, we want to make these for you 3D printed, and we have a lot of the parts on our machine are 3D printed as well. So they offered to beat the price of any manufacturer. So, and they're also building a bunch of machines as well. So we're going to combine our orders and bring down the price even more. It's really exciting.
Yeah,
and
that's excellent.
We're glad that we got all this work done before because, we're really confident in our ability.
You'll also notice on our Kickstarter that the assembled machines will be delivered later on, as well as the black versions of the kits. And we also did that intentionally because that will allow us to deliver the most simple kits as soon as we possibly can, and then have a little bit more time to, for example, assemble the assembled kits and then deliver those on time as well. So that's going to be a process that we'll undergo here locally so that we can make sure that we're our own quality control and nobody has to worry about us shipping the machines off, getting them assembled in China, and then getting them distributed straight to the location and then having a problem with quality control.
Okay, that makes good sense. So, do you already have a website up?
Yep.
And what is that website?
It's www.cienci.com. So SIENCI.com. So the first part of our company name.
Excellent. So if people want to go there now, it's already up and running and they can take a peek.
Yep. Oh, yeah. It's been up and running for a long time. They can check out our blog section, which has posts going all the way back from since we started this project up until now. We have a tab that'll link you to our Kickstarter so that you can check out our Kickstarter. We have an email that you can reach us at if you have any questions, hi@cnc.com.
And YouTube.
And yeah, and we have a YouTube
channel,
link.
Instagram, Twitter, the whole 9 yards.
We have a very active Twitter and Facebook page. So if you're interested in any of the current projects that we're working on, they show up almost daily.
Excellent. So if you had one other aspect of this project that you could do as a stretch goal, what would it be?
We haven't thought too much about stretch goals. When I was thinking about it, maybe we can add different things that people would need when they CNC mill, and we put in a thing rather than a stretch goal. If you order your machines earlier, we add a couple of things like a clamps or extra bits or double-sided tape, a couple of things like that will help beginner CNC machinists to use their machine.
Mm-hmm.
So actually, all of the backers that have backed us, the time's up for the time frame of the first week, but all the backers that have backed up until 7 o'clock today, they will have received the early bird extras.
Yeah.
Okay. Now, we're recording this on the 25th, and your campaign at Kickstarter ends on September 17th. Is that correct?
Yep.
Okay. So by the time this is out, you'll have probably 2 weeks in order to take care, about a little over 2 weeks to take advantage of this if this is something that interests you, audience. So one of the things that kind of surprised me about your project is that you made it open source. Why is that?
Today's episode is sponsored by The Maker's Guide, creator of the Triple Edge Finder. Get the edge you need, save time and frustration on your CNC project, and make setup a snap. Save time and material. Set up your workpiece on your CNC router table faster than ever. Accurately set your Z-axis height first time, every time. Automatically locate the corner or edge of a workpiece. Reset your starting point in the middle of a program. Quality crafted right here in the USA on US-made CNC machines. Get the edge you need today. Go to www.themakersguide.com/edge. The Maker's Guide. Useful tools for makers.
One of the things that kind of surprised me about your project is that you made it open source. Why is that?
Well, as I was saying, our company goal is to make rapid prototyping accessible, and another part of that is for people to either be able to fix their own machines by looking at the designs that were provided by the creator, or being able to create their own machines. So obviously, we tack on our own margins to the machines because we need to feed ourselves, right? But if you are interested in building your own machines, it's totally possible using the designs that we have. And if you want to modify them, build something else, or get inspired, it's totally possible.
All of the materials that we use to design the machine, you can order it from a local hardware store and a combination of a few online orders. And so it's pretty easy to assemble the materials yourself and put it together. We'll be releasing the plans for the machine after we've added a few upgrades from feedback that we received from beta testers. And so that'll be going up at the end of the Kickstarter.
Do you think you'll eventually have an online marketplace as well where people can order the parts from you direct?
Yeah, obviously people will have they'll need new parts, so we'll either provide people with a place that they can go and get them, or we'll provide them ourselves. Luckily, in America and Canada, there's a couple of companies that do provide the tools, the hardware that you need, and those are also open source as well. So, yeah, that's the plan.
Okay. Is there any question that I haven't asked you that you'd like to, or any topic that you'd like to talk about and share with our listeners?
Well, one thing that we haven't addressed is kind of we get a lot of questions as to why we would decide to move to open sourcing our project instead of kind of patenting the technology that we've made and restricting it to sales among ourselves. And usually the way that we answer that is that the same phrase that Andy's been reiterating is that kind of we're trying to make this technology more accessible. And so the way we see it is it'd be much more of a benefit to the CNC community to release these open source plans for anyone to build the machine, because then people can take our design, even though we think our design's pretty great, there's always a possibility that someone can take our design and make it better. And then that would just assist the community even more. Yeah. One of the goals that we're trying to reach is that 3D printing, with all the open source and technology advancement, has become a really common name, even with people who aren't familiar with the technology. And so everyone knows that you can do rapid prototyping with 3D printing. And we're kind of trying to do the same thing with CNC machining. We're trying to make it a more household name because of how accessible it is. And so that's why we decided we'll make it open source, we'll give it to the community, and just let them go at it.
Yeah. And what it really comes down to is that we love making machines. We're mechanical engineers. It's what we like doing. And so it's not just that machine that we're going to make and go home and go to sleep. It's we're going to make that. we're gonna make the machines that are gonna make that, and then like who knows, right?
Yeah, we have pretty large plans. Like when this Kickstarter goes through, we know that we have a path for other machines that we're going to be releasing that we think everyone will agree is just as beneficial and hopefully just as influential as this machine is.
Excellent. Now, it's funny that you mentioned the recognition of people that people have for 3D printing, But when you mention CNC machines, it doesn't quite have that same thing. You usually have to explain it to them, and I end up saying, well, it's kind of like the reverse of 3D printing, and then they go, oh. But, it's really a shame that the older technology has to be explained by the newer. So
Yep.
Yeah, it's strange that way, and it's also very strange, like, because 3D printing isn't the be-all, end-all of rapid prototyping technology. It's just one of the technologies that's available in the rapid prototyping toolbox.
Yep.
Like, you've got vacuum forming machines, you've got CNC machines, and you've got a bunch of hand tools that you could use for kind of rapid prototyping.
Laser cutters.
Oh, yeah, you've got laser cutters. Like, the toolbox is quite large, but we don't want the restriction to be that everyone's just focusing on 3D printing as the main rapid prototyping technology. Because sure, you can do like sintering in 3D printers so that you can make metal and you can make plastics and you can make all sorts of alloys, but those machines are costing tens of thousands of dollars.
Or millions.
Or upwards of millions, whereas you can just take a desktop CNC machine and carve something out of aluminum quite easily, in fact, or you could carve it out of foam and use a lost foam casting method, and then there you have an aluminum or some other metal casting of exactly what you want without paying tens or hundreds of thousands of dollars for some sort of metal 3D printer.
Yeah, that's exactly, you hit it on the nose. The ability to go out and rapidly create what you have floating around in your head from available tools that you can, out in your shop. I mean, that is going to be the future and the present of design and manufacturing, my opinion, anyway. So you're singing to the choir. Anyway, I've really enjoyed having you gentlemen on our show. I think you're in the midst of probably the busiest month of your lives up to this point, because I know how many different things you must be going through to keep this campaign rolling and to get everything on track. So I appreciate you taking the time and for reaching out to me to come on the show.
Yeah, I really enjoyed talking.
Yeah. So
thanks for having us.
If anyone wants to see your project one more time, they can go to
CNC.com. So that's www.sienci.com.
Okay.
Or you can find us on Facebook or Twitter or Kickstarter. You just type in that name.
Yeah, if you go to fabrication tools or technology under Kickstarter, we're actually one of the top ones that show up. So,
well, we're featured today, but I think once the podcast gets out, it probably won't be anymore.
Why is that?
Because the featured Kickstarters, they constantly change.
Uh-huh. Okay. I thought you were saying that as the result of being interviewed on a podcast, they would take you down as a feature. No.
But if you search up like CNC machine on Kickstarter, we should show up.
Yep.
Yeah, I searched for you under CNC, the initials CNC, and it pops up on the first page, first row. So it's doing very well. So I don't think anybody's going to have any trouble finding you on there. And I really look forward to watching your success as you go forward.
Thanks.
Thank you very much.
You're welcome. Okay, we've been talking with Andy Lee and Chris Thorogood from CNC Labs. And I hope you enjoyed that and found it useful. You can find out more about this project through the show notes, which will be on cncroutertips.com/38. I often mention many different types of software during the episodes and hardware and cutters, and it can get a little confusing. So what I did was I put together a page on my website, cncroutertips.com/resources. And on that page, I list all sorts of resources there, from books to tools to software, all the things that I use that make my CNC experience better and easier. And I hope you'll check it out. So again, it's cncroutertips.com/resources. Now, if you'd like to have your question featured on the air, here's how. Need help? Ask me about your CNC router question on my podcast, the CNC Router Tips Podcast. I'll be glad to help or try and get you the help you need. I want this podcast to be a fun and personal experience for everyone and helpful. So let's keep it real and ask sensible questions. Please use common sense and show courtesy to everyone. That way everybody wins. Here are some guidelines to ensure that your question is qualified to be featured on the show. Please keep your questions under 1 minute in length. If it goes a little over that, that's fine, but don't ramble. If you have a website and URL, you're allowed to share it, but only once during the recording. Spammy or disrespectful or deeply private questions will not be considered for the podcast. If you need to ask more than one question, just make each question a separate voicemail. Well, folks, that's a wrap on episode 38 of the CNC Router Tips Podcast. Thank you for listening in. If you would like to get in touch with us, you can reach me on Twitter at Bill Griggs. And I'd really love it if you would leave a rating and review on iTunes for the CNC Router Tips Podcast. Thank you, folks, and have a great day.